dot product. So I kind of typed them in. I'm just saying like this is the dot product between here. I just don't have a symbol when I type it on here to put. So that's just the dot product. And I missed one, so we're gonna have to make our own little box. All right, so properties of dot product. So it's saying if you take the dot product of V and W, like highlighter, like multiplication, the order doesn't matter. So this is equivalent. Okay. If you have a scalar or a vector in front of it, and two vectors are adding, it's kind of like the distribution property. So it's the dot product of V and W and the dot product of V and X. Okay? And again, these dots are supposed to be bigger for the dot product. It's really dumb. I just didn't type them in there again because I couldn't. So dot product dots are bigger. Don't ask me. Don't ask. All right. So this one's kind of weird. It's kind of like this transitive property. So it's saying you can take this is a scalar. Okay, so it's just a number. You can take that constant, which is also why I'd say k. Sometimes I call it k, sometimes I call it c. It's just weird. So the constant times the vector, and then once you do that, you can do the dot product. Or it's saying you can do the scalar to the w, and then do the dot product. So it's kind of like grouped up. It's just saying it doesn't matter which one you multiply the scalar to, but you have to multiply it at some point. Okay, and then if you have 0 and a vector dot product, it's just 0. And if you have a vector, the same vector with the dot product, it's actually the same thing as the magnitude squared. Okay, so moving on to the next page. These are here. I'll keep referencing them when we need them. Okay. Ooh, I forgot about this. All right, so this is kind of weird. If you have, and this is going into that last thing we just talked about, two vectors with the dot product between them, or taking the, sorry, this is weird to say. It's so hard not to say multiplication when it looks like it. So when you take the dot product of the same two vectors, I wrote this, right? Okay. So we have to then remember that the magnitude of V is just the square root of that vector. Okay. So let's do this. So use the dot product to find the magnitude of each vector. So back up. To get rid of the square, you square root, right? So that's how this came about. So it's kind of weird. So we're just finding the magnitude with this dot product. And it's like doing the same thing twice. So instead of having 10 and another number, or you're trying to find the difference between the vectors, you have it. This is really easy. It's almost like I don't need to go over it, but I will. So you're literally just doing 10 squared and 24 squared all under the square root. That's all it is. It's exactly the same thing. This is just overcomplicating it, but I have to write it in there. So that gives you 100, and 24 squared is a number I don't remember. 556. So that's 660. My bad, I'm really losing it. 676, and that actually is the square root of 26. So the magnitude of this dot product is 26. If we looked at k, which is set up a little bit differently, you do it the same way. Okay, so to find the magnitude, you're just going to take 14 squared and then negative 3 squared. 14 squared is 196. 3 squared is 9. So that gets you 205. And you can either use the decimal or you can try to simplify it. So we're going to try to simplify it because that's what Con did and I didn't realize it. So 205 divided by 5 is 41. Our issue is 41 is a prime number, so that's actually it. If you have the decimal of it, it's approximately 14.32 something, okay? All right, last two examples. Okay, I'm just going to do this on this video since this was kind of a review. So, angle between two vectors. Okay, so if the angle between the vector is 90 degrees, then the vectors are perpendicular, and that we should know. Perpendicular lines create 90-degree angles, if the angle is, if the angle between the vector is 0 degrees or 180 degrees, then they're going to be parallel. Okay. So, where is my formula? Oh, I forgot to give it to you. Okay, so let me write this down. So this is the formula I'm going to use, and it says if theta is the angle between non-zero vectors v and w, so let me kind of draw this out. I totally must have forgot to put this in your notes, so I do apologize. And it's not helping my scatterbrain mentality today. Okay, so let's say this is vector v, and this is vector w, and you want to find the angle from here to here, okay? That's the dots that they make. Okay, so you can find it by doing cosine of theta, and then all of this. So go ahead and write this down. Okay, and I'm going to put like a little box around it. Oops, daisy. Or does that make this more complicated than I need to? Okay. So just use that as a reference. Okay, so to find the angles between each pair. Okay, so we have 8 and -7 for vector r, and we have -7 and -3. All right, so we can do this split up, and I think that's going to be the easiest way to do that. So we're going to find each component. So we're going to do the first, and we're going to do the dot product of v and w is what the rule says. So in this situation, it's r and v. So that's our first step. So we're going to find the dot product. So we're going to take 8 times -7 and -7 times -3. If you take that and just type in your calculator, you can. I don't really care. So you get -35. Second step we're going to do is we're going to find the magnitudes of these separately. So in this situation, I'm going to find the magnitude of r first. So 8 squared is 64, 7 squared is 49. Okay, if you put that together, that's 113. Okay, so third step, we're going to do we're just doing this all step by, or chunk by chunk. We're going to do the magnitude of v. So you're going to do 49 plus 9, and 49 plus 9 is 58. Okay, so now we're just going to put it all together. So we have the fourth step, I guess you can say. Cosine of theta equals -35 over the square root of 113 times the square root of 58. Now, technically, you can put these two together. Okay, so if you take 113 and 58, and it's a lot easier to do this so you don't make mistakes, because what happens is you need to put parentheses on the bottom to do this, and some people don't do that, so then they get real goofy answers. So I'm just going to multiply. So these two multiplied together are 6,554. So you do inverse cosine of -35 divided by the square root of 6,554, and you get 115 degrees, or 115.615 degrees, okay?